Hello. Good evening, my 11th standard warriors. Are you ready for calculus? One of the most dreadful topic and one of the most interesting topic. It looks scary at the start, but trust me, it's one of the most interesting conceptual topic and it has variety of applications. And guess who invented this? Well, there is no clear winner. There is Leibniz on one side and there is Newton on the other side. Both have been credited as the inventors of the calculus. Both have their own reasons. There was a war going on between them some hundreds of years back as to who was the real inventor of calculus. But we are not bothered about it right now. Let's focus on how to actually use it in physics with me, Shreyas, your physics master teacher on this channel. Nice to see all of you posting from which city you are. Nice to see all my lovely warriors. Hi Neha, hi Viknesh, Shivani, hi Riyaz, hello Krishna, Sneha, hi Srinidhi, Sharwin, good evening Sudarshan, good evening. Wow, we have Fat Zombie YouTube, hi Rajani, hello Balaji, good evening everyone. Nice to know all of you. What's the use of calculus? Complete. That's what you're going to see. How we are going to use calculus to solve problems. It has variety of applications like finding the center of mass of a body, or solving a problem where things are not uniform, or solving a problem where things are dependent with time, or things are dependent with position. Things keep varying and there is no uniformity in that scenario. Whenever you have these kind of things, that's when you use calculus. Also finding areas of random shapes, also finding the rate of change, slope, instantaneous values, that's where you use calculus. Don't worry like it, I'm going to keep it easy. So before we go ahead, I hope you have smashed the like button out there. It's a lovely small little like button, a small thumbs up, go smash that like button, because it means that you love us, it means you support us, and that's the only fees for attending the lectures out here. And in case you do not want to miss any of the classes, go smash that subscribe button down there so that you do not miss any of the classes. And yes, the entire PDF of today's session will be available on your Telegram channel. Okay, so what are we going to do first? Let me show you that. See guys, we are going to start with instantaneous velocity, acceleration, and the graphical way of approaching derivatives. Today is only graphical. Like you can see, on Friday 7:30, I'm going to discuss how to see the analytical, the formulas, the crazy formulas, the rules for solving those derivative problems, all of that on Friday. Special session here, and this is also a very special session for all of you. Yes, this one, the Wednesday 7:31. All my micro courses, pro subscription plans revealed. Also, which books you should use for physics and what should be your studying strategy in physics. That's what the plan is on Wednesday 7:30. So be there. It's for all 11th as well as 12th students. 2022 and 2023, and other things are for your seniors out there who are in 12th grade or going to give the examination. Now please remember, there is also an Olympiad Wizard test for all the 11th and 12th standard students. So you can prepare in Vedantu for all the Olympiad exams like the Physics Olympiad, which is NSCP, then the Chemistry Olympiad, Biology Olympiad, KVPY examination, RMO, and so many other examinations. The test, please note it down. It's on 13th of June and it is from 5 p.m. to 6 p.m. and it is a free of cost test. So guys, start your journey for Olympiad preparation from this course. It's a very important course for all of you. Yes, in case it will be sent to you on Telegram channel as well, but attend the class so that you'll get to know how to actually use it. Thank you, Abhitech Telugu. Baundi. I hope you are Baundi. Okay. Well, Surya, hope your exam goes well on the birthday, and I hope you really have a great year after that. Hopefully you will qualify and clear that examination. Hi Lipika Garg, welcome. Thank you for all the love. Suchi Mama, nice to see you back. Is this chapter also known as motion in a straight line? Yes, Ankit, correcto. And thank you, Riaz. It's only because of your love, support, and your, continuous spreading of all the comments and the videos that you share on your social media, the way you guys tag us on Instagram and all that. Thank you guys so much. Hi Tiraz Mariam, welcome aboard. Hi Kalyani, hello Gamira. welcome. And guys, if you want to be one of the toppers, because already 1 in 2 Vedantu students are already qualified in JEE Advanced. That's such a beautiful thing. Come on, think about it. And there are so many students who have got 100 percentile score, and there are so many students above 99 percentile in JEE Mains, and more than 600, close to 700 students above 90 percentile in JEE Mains again. Guys, these are phenomenal results from Vedantu, that to online learning. These are unprecedented numbers, something which you would never hear. And all of this is because of our continuous effort by all the lovely master teachers, the courses we design, the micro courses that we have, so many topics being covered free of cost, also the modules that we give, the test series, the doubt solving, all of this combined together with the students' motivation and dedication and hard work obviously gives rise to these results. So if you want to know more about these plans, go ahead. You have all the 3 versions. You have monthly subscription, yearly subscription, and you get a lot of money off when you use the coupon code SHHPRO. The link for joining is there in the description box below. So let's get started and let's just quickly revise few things. Hi Divya, welcome aboard. Good evening. Nice to see you, Dikshita. Guys, I'm feeling hungry. If you excuse me, can I start the lecture with a small piece of this dairy milk silk that I just have? I don't know how many of you love dairy milk silk. I love this. This is so sweet. No, says Neha. Wow, this is my dairy milk silk out here. Yeah, it's beautiful. You should try this. I have it. Vitnesh also loves it. Oh my god, Neha is already starving. Yes, story dreams is the first lecture. Tarun, nice to see you back over here. Oh sure, why not, Ronak? I'll give you, I don't know how. Please catch, okay? Projectile motion. Okay, I hope it landed correctly. So let's do a quick revision. First of all, let's talk about displacement. Okay, now imagine, all right, imagine, you have a vehicle and it is traveling. Okay, it is traveling from one end to the other. So I want to know the displacement. So this is the initial position, this is the final position. What you define displacement as is the change in the position. Final position minus initial position. If it is located at some point over here, if it was initially located at some point here, the difference of the positions gives you the displacement. So you can see S is equal to final minus initial. Keep this in mind. Okay, one more thing before going ahead, this can be also written down as, okay, that delta symbol should not be there over here, it's not needed. Okay, this can be also written down as delta X. Please understand this delta symbol stands for change. So change in anything is represented by the symbol called delta. Delta X is change in position, delta P is change in momentum, delta F is change in force, delta S is change in displacement, delta V is change in velocity, delta donkey is change in number of donkeys. Okay, let's get going. Next, average speed. These are just quick revisions. Okay, average speed. Imagine a car which is accelerating, decelerating because there are speed breakers, there is traffic, suddenly there is an empty stretch of road, so it increases the speed. So the car has variable velocity, but the average speed is that constant speed with which you should travel to reach your destination in the same time. I'll just repeat. If you have varying speed, you reach your destination in some time, right? It's a varying speed. So average speed is that constant speed. It's slightly lower than the maximum. It's obviously higher than the minimum. It's somewhere in between. It's that constant speed with which you should travel to reach your destination from here to there in the same time. That's what it is. Nice to see you, Avdesh. Oh, Vijay Kumar, you're a little bit late, maybe 5 minutes late, and you also missed a nice dairy milk silk. I just gave it to everyone. Okay. So average velocity, by the way, the symbol for average is this, angular brackets. This is the symbol for average. So if I write F and this angular brackets, then it is average force. If I write this, average momentum, P stands for momentum. If I write this, it's average velocity. If I write this, it's average acceleration. Okay, so that's the symbol for average. Keep this in mind. It's distance traveled divided by time, standard value. Everybody knows this. Now, remember, Speed is a scalar quantity. Okay, it does not have direction. Okay, so there is no bar over here. The next quantity is velocity. So if you travel from one point to the other point, this is initial, that's final, this is your displacement vector. And if I draw it graphically, okay, if I draw it graphically, so look at this graph. Please understand, graph is not the same as path. Everybody agrees to this? Understand the difference between a graph and the path. Path is the actual way, actual manner in which you traveled. Graph is just a way to show where you are at what time, where you are, what you are doing at what time. It tells you information. It is not the actual way in which you traveled. The person did not actually travel along this line. The person would have gone somewhere else. I don't know. But this is just telling you where you are at what time. So my x coordinate, my x position is somewhat like this. This is a graph which says how my x position is changing with time. At some time, this was my position. At some other time, this was my position. At some more time, this is my position. Do you see? This is my initial position. This is my final position. So this is the change in the position. All right, these are the coordinates. This is the x coordinate, this is the x coordinate. The difference between them is the change in the position. This one over here is the time interval from here to here. That's the interval. Delta stands for interval, change, time gap. Any gap or change is represented by delta. That's your time gap. So in this gap, I have moved this much. I have gone from here to there. Yep, position versus time. This is position versus time graph. Very good, very good. So look at the way it has been defined. I hope you're writing all these things down in your notes out there besides your laptop or mobile phone. Look at this symbol is these angular brackets because it is average. There is a symbol over here, bar or vector notation, because it's velocity, it's a vector. It's delta x by delta t. Delta x by delta t. This is very, very important. Delta x means displacement. Yes, Riyaz, delta means change. Any change is represented as delta. If I ask you, what's your delta in life? That means how much have you changed in life? That's the simple way of putting it out there. It is also known, remember, by the way, this delta x is nothing but change in position, which is displacement. Displacement, correct? Displacement is nothing but change in position, x. Change in x, change in position, that's what it is. Now this line is very important, is the average slope of position versus time graph. Is the average slope, yes, the arrow is essential, Kalyani, because it's a vector quantity. If you don't put that arrow, then mathematically you are wrong, okay? Yep, it will be, Shruti, I give you all the homework questions and also the DPPs are given to you in the assignments in our platform when you download the app and you enroll into courses, okay? Now, look at this, guys. This is very important. Average slope means if I draw a line from here to here, if I draw a line from here to here, connecting this point and this point, then this is the change in the vertical axis, okay, delta x, and this much is the change in the horizontal axis. In this case, it is delta t. Average slope is nothing but change in x, vertical axis, upon change in horizontal axis. So that's the meaning of average slope. It's nothing but change in the vertical, okay, change in the vertical upon the change in the horizontal. That's how you're going to remember the value of slope. Slope is nothing but, this word means steepness, how steep it is, how steep it is. If it is very steep, then the slope is very large. This delta x is very large. If steepness is very less, the slope is very less. If the slope is negative, it's going down. If the slope or the steepness is 0, that means there is no change in the vertical direction. It's just flat. That's the meaning of slope. Are you guys getting it? Are you guys getting it? Yes. Hold on, Jaivan. Now we are going to come to all of that. Did you guys understand what is slope? Did you guys understand what is steepness? Positive, 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 more positive. Less positive, less positive, less positive, 0. 0 say less is negative, 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 more negative, more negative, more negative, less negative, less negative, less negative, 0. That's how slope works. That's how slope works. Kavya, that's what it is. It's how much you change in vertical upon how much you change in horizontal. When you go this much, how much do you rise up? or how much do you fall. That's the meaning of steepness or slope. I hope that's clear. Yep, I hope this is clear. Sneha, Kavya, everyone out there. Okay. Oh, well. Okay, great. Chalo, let's get going. So everybody has got this. So I hope you now are going to remember average velocity is displacement by time. Displacement is vector, time is scalar. Displacement divided by time is average velocity, and graphically it is the average value of the slope, how much you change in vertical, that is displacement upon the time gap. That's all it is. Let's see whether you can solve some questions. Whether you can solve your questions. Okay, come on. Shamukh, I am from Bangalore right now, but originally I am from Pune. Come on, let's see how many of you can do this question coming up on your screen. Figure this out. There is a graph, position versus time. Each square box is 1 unit by 1 unit SI. So figure this out. In the first 3 seconds, what is the average velocity in the first 3 seconds? Let's see how many of you can get this. Krishna, no, it is not enough for NEET. Bacha log, any doubt you have, there are 2 ways you can approach me. Number 1, you can contact me on my Instagram handle if you have Instagram. Yes, follow me and then post your doubt. Only then I will be able to reply to it. Number 2, you can post all your doubts in the comment section and I reply to all the comments within few days. Okay, so both the ways I have told you. Yes, resume I have. Okay. Yes, Sanjeev, we are going to start a different kind of course because the long-term courses will be on JEE Enthuse. It's not going to be the same thing on obviously catalysis. It has to be different. Okay, glad to see that, Abhijit. Okay, so Vinkesh, I do provide the homework questions after the class. It's there in the PDF. You can check it out, bacha. Okay, cool. Now, a lot of you are saying B, somebody is saying C. Well. In the first 3 seconds, this is 1, this is 2, this is 3 seconds. At 3 seconds, check this out. What is this value? Well, this is 2, this is 3, this is 4, this is 5. Okay, this is 3, this is 4, this is 5. 2, 3, 4, 5. Come on, guys. Oh, don't worry, guys. Now, first of all, think what is the formula for average velocity? The value for average velocity is displacement, which is nothing but final position minus initial position divided by time, right? Now think about it. What is the value of my final position? Is it not 5 meters? Is it not 5 meters, guys? What is the value of initial position? Initial means this. This is initial because time is just 0. You just started. So what's the position? It's 2 divided by time. Obviously, what's the time gap? It's 3 seconds. So guys, what should the answer be? Yep. Oh, Neha, you got it wrong. It's not 5 by 3. A lot of people make that mistake. Initial position is not 2. Be careful. Sorry, it's not 0. It's 2. A lot of people divide 5 by 3. Be careful, guys. It's not 5 by 3. It's change. Look at the change. This is the change upon this. Yes, the answer is 1 meters per second. I hope you see that because 5 minus 2 is 3. So this is 1 meters per second. Beautiful, guys. I hope you guys understood how to solve this question. Yep, happens, Nia. It's okay. Yes. Okay, Lakshya Prasadhan, you can post all your queries after the session is over. Okay, I will reply to all your queries after the session in the comment section out there. Okay, that's the answer, option C. Let's see whether you can solve this question. Slight variation is this. In 4 seconds, the graph is different. Let's see whether all my warriors can get this question in the first 4 seconds. What's the value of the average velocity? Come on, my warriors. Exactly, Kavya. The object already started from a particular value, 2 meters. Okay, got it, says Don't Know Gaming. Very good. Hi, Tirthankar Konwar. Welcome aboard. Well, Jayavant, very good. Finally, you confirmed the answer. Okay, come on, my warriors. Kumara, please ask Wazim sir. Okay, I cannot say Wazim sir, please do this. He has his own plans. So please, you can post up comments or tell him on his Instagram channel. Okay, sir, I'm only 346 kilometers from Bangalore. I can reach you in 5 hours because I'm Chennai. Well, Vijay Kumar, I would love to meet all of you. In fact, that would be lovely. Some of you are confused between D and C. One of you, Sivan, said A also. Oh, interesting. Well, guys, here it is. Where is that? Yeah, there we go. How do we look at this? 4 seconds. This is 1, this is 2, this is 3, this is 4. So at 4 seconds, this is the value. At 0 seconds, this is 1, this is 2, this is 3, this is 4. This is the value. Again, average velocity is final position minus initial position divided by time. This is the formula, displacement by time. Final position, what is it? Oh, it's 2. Initial position, this is initial. What is it? It is 4 divided by time. What's the time? It's 4. It's nothing but minus 2 by 4, which is minus half, which is minus 0.5 meters per second. Guys, look at the slope. Look at the slope. The slope is going to be negative. It's not minus 2. I think some of you flipped this. They found out the inverse of that. That's why they got C. You made a silly mistake. You divided time with displacement. No, velocity is displacement by time. Please do not do such mistakes. Yeah, it's the average value of the slope, which is minus 0.5 meters per second. Yes, computer G, lock कीजिए option D. Okay, very good. Let's get going to the next one. So I feel now you have a fair idea about what is average velocity. Everybody has a fair idea about what is average velocity. Now you might be interested in knowing what is instantaneous velocity. The speedometer on your bike. Which kind of velocity does it show? The speedometer on your bike, in your car, what kind of velocity does it show? Does it show average or does it show instantaneous? Crystal clear, says Tirzan, very good. Sudarshan, I am conducting a special class on Wednesday at 7:30. I will explain everything how you can enroll into my micro courses. And meanwhile, guys, I am even more hungry. Sorry, guys, I will have to eat one more piece of your chocolate. Rank Booster Series, Dhanshekharan, it already started, you missed it. Please hit the bell icon so that you do not miss. Morning only I conducted one class on kinematics. Okay, come on, let's do this. Very good, instantaneous. Now, how do we talk about instantaneous velocity? Many people get this. I have created a beautiful story so that you guys understand what is instantaneous, derivatives, everything. Now on, till the end of the class, be very attentive because this is one of the most important moment of your life. Once you understand this, nobody can stop you from solving and getting confidence in calculus problems. So be very attentive. If you lose track, that's it. You're going to lose it. Okay, so follow me very closely. So let's imagine a person riding in a car. Okay, let's imagine a person riding in the car. Okay, just imagine. Okay, but he's not going with constant speed. He might be going with varying speed and his positions might not change uniformly. Velocity might not be uniform. It could be anything. It's just a random motion in 1D. Now, these are the two positions of the car. Look at that. Look at that. These are the two positions of the car. The car is moving in 1D. Delta x is the change in the position, correct? Let's look at it graphically. Let's look at it graphically. So basically in delta t time, the car has moved delta x. Graphically, how will it look? Observe closely. At some time t, when you start your watch, all right, the position is x. At some time, the position is some x. I don't know, it could be 1 meter, 1.3 meters, I don't know, it's something. After some more time, t plus delta t. Do you understand why delta t added? If this is t, t plus delta t will give you this time. If this is 3 seconds, 3 seconds plus 2 seconds is 5 seconds. That's what it stands for. This is my new point on the graph. You can see this is representing this position. This is representing that position, correcto? And you can see the position has changed by delta x. So hence the new position. What is the new position? X plus delta x. X plus delta x is x plus delta x. Everybody clear? Everybody clear till this point? Let me know. Everybody clear till this point? Let me know by putting up some fire or yo or saying clear till this point. Great, great, great. Thank you, Job Cherian. Great. Now, if I ask you, is is this value delta x by delta t, is it average or instantaneous? Is this average or instantaneous? What will your answer be? Come on guys, think about it. Think about it. What will be the answer? Yes, I'm coming to that, Tech Telgo, I'm coming to that. Hold on. It is not instantaneous. That's where you guys went wrong. No, it's not instantaneous. It is average. Correcto. Because this time interval is large. In this time interval, remember I was asking you to imagine a car which is moving non-uniformly. In this time, when the car moved, it would have changed its speed. It would have varied its speed. So that displacement upon that time won't be instantaneous. Is that clear? So hence, in order to find instantaneous velocity at some time, I feel we should bring those cars' positions closer. Obviously, you cannot have two different positions, two far away positions. That will give you average velocity because you are giving the car an opportunity. You are giving the car an opportunity to change the speed. You do not want the car to change the speed because you want, what is the speed at this instant? What is the velocity as this instant? You do not give it a chance to change the velocity. Keep this in mind. Okay, so what do? I have two distinct points. I bring them closer. So look at that. The car was a little bit far away. Okay, so I bring it a little bit closer. Naturally, those corresponding points on the graph, what will happen? Delta t, the time interval becomes small. Delta x will become small. So this point and this point have come closer, but they are not close enough. They are not close enough. Do you see that? It's still not instantaneous. Guys, concentrate. We'll wish everybody happy birthday, etc. at the end of the class. Trust me on that. This is very important right now. Okay, so guys, do you see that these 2 points have been brought very close? If they have been brought really close, that's where I'm trying to find instantaneous, but it's still not instantaneous because these 2 points are still little bit far away. It's still little bit far away. Understand that. Average is when you have two different points of this. Very simple. Instantaneous is when you bring that time interval close by. We are trying to make the time interval small, very small, because I want the speed at that instant. A lot of people think, and they get fooled in the school, they think instantaneous means, sir, take time as 1 second. In 1 second, how much do you go? That is instantaneous. I felt like banging my head after that because guys, that's not instantaneous. Come on, in 1 second also your speed can change. How the hell is that instantaneous? It's just an unit of velocity. It's not instantaneous. Please understand that. Obviously, you can have time intervals smaller than 1 second. You bring these points closer. This is still not instantaneous. It's still average because the time interval is large. You make it so small. How small can you make? How small can you make a time interval? What is the number which is smaller than 1 second, guys? Is it 0.1 second? Is it 0.2 seconds? Is it 0.01 seconds? Is it 0.001 seconds? What do you think is the smallest value of time interval? 0? No, you cannot have 0. You cannot have difference. No. A job Cherian, please don't spam. We are not going to answer that. No, is there, Kavya, think about it more. Is there no number smaller than 0.001 seconds? Even in that 0.001 seconds, there is a chance, there is an opportunity for that velocity to change. So I need to make it really, really small so that it doesn't even get a chance to change its velocity. So what's that number? What's that number? That's going to be very small number, and we are going to keep those two positions very close, and that time interval is going to tend to 0. It's going to be very small but not 0, because you cannot say I will give you no time and you should move. You'll be like, what the hell, man? You give me some time, only then I can move, but don't give me large time. How large then? Very small actually. You need to give me very small time so that I just move. Very small time, very, very small. It's very small, tending to 0. And then the displacement will also tend to 0. Now on the screen, I cannot show that delta x. Please understand, that's why I've shown two positions. But actually it's very close by. It's not to be seen, but it's close by. I need to show two positions. That's why I have shown it over there. So this 2 points will come close by. delta t, this symbol stands for tends to, this symbol also stands for tends to, this interval becomes very, very small. Very, very small. Okay, so this is an English channel. Yep, this is an English channel. No, there is a number smaller, Dikshita, than 0. Infinite zeros and 1. I'll tell you which is the number smaller than 0.0 bar 1. I'll tell you which number is smaller. That whole thing divided by 2. You're like, oh yeah, that's smaller than that number. Sir, is that the smallest number then? No, I can divide it by infinity. And that whole thing divided by infinity. And that whole thing divided by infinity. I can keep making it smaller. So there is no such number which you can write that this is the smallest number. But yeah, let's just imagine it like a concept. Yeah, there is a smallest number, which is a very small interval in which only you can talk about truly instantaneous value. Yep, you can talk truly about instantaneous value. Okay, great. Is that clear? Is that clear, everyone? Now, how do you write this? You do not want to write such a big thing. Delta x tends to 0 means delta x is very small. It's not 0. It's very smallest number. Instead of writing all these pieces of information, there is a symbol of writing it. And that symbol is dx and dt. That symbol is dx and dt. Job chariot, don't spam. We'll talk about your birthday later on. Yes, we are going to find that out. That's the mystery which I'm going to reveal today. How are we going to deal with such numbers whose values themselves are not known? Hold on. So, if I say dp, oops, it does not mean your display picture. If I say dp, it means small change in momentum. If I say df, it means small change in force. If I say dx, it means small change in position. If I say dt, it means small change in time. If I say dv, it means small change in velocity, like that. I hope you guys get it. Yes, we are going to come to it, Vignesh. Hold on. We are going to come to it. Shanmukh, everyone. Now, if you guys understand what this symbol means, so please understand dx means delta x tends to 0, but delta x not equal to 0. That's the meaning of dx. That's the true meaning. You cannot write dx is not equal to 0.001. No, it's not. It's not that. Please understand that. It's not equal to that. Okay. It's a very small number. Nobody can write that number. Now, these 2 points have come very close. So, this is my final way of which I can write instantaneous velocity. V is dx by dt. Look at that. Dx by dt. What is this dx? It's a very, very small displacement. And what is dt? It's very, very small time. How small? Extremely small. Extremely small. Now you'll be like, sir, what the hell are you teaching, sir? I mean, do you know the value of dx? No. Do you know the value of dt? No. And you are defining v. How the hell? I don't know numerator, I don't know denominator, and you are defining v. How is that possible? Hold on. I am going to find that value. Are you guys now interested? Yes, there is a lot of difference, Vignesh, between delta x and dx. Delta x can be written down as 0.1 second, 10 seconds, 5 seconds, 0.5 seconds, etc. But dx, you cannot write down the value. That's the difference between delta and d. Technically, both of them are changes, but dx is infinitely small change in any quantity. Okay, I hope that's clear. Everybody let me know by writing clear. Vignesh, I hope that's clear, and everybody else. And what is dx by dt? Dx by dt, hold on Kalyani, initially it looks confusing, but you will not be. Okay, yes. Dx by dt, this number, this ratio, what is it called? It is called as the rate of change of position. What is changing? Position. With respect to whom? Time. It is called rate of change of position with respect to time. Come on guys, think and tell me. If I write dv by dt, what will I call this as? Rate of change of velocity. Velocity. dv means change in velocity by time. Okay. Similarly, if I write dp by dt, what does it mean? Rate of change of momentum with time. If I write dA by dt, it means rate of change of area with respect to time. If I write dv by dx, it means rate of change of velocity with respect to x. If I write dF by dV, it means rate of change of force with respect to velocity. I hope this is clear. Do you guys understand what these symbols mean now? Did you guys get a hang of it? Yep. So rate of change of numerator divided by rate of with respect to that denominator quantity. Yep, that's what it means physically. This is also called as, oops, where did it go? Yep, here. This is also called as the derivative or differentiation. Yes, that word which you are looking for, derivative or differentiation of x with respect to time. That's all. It's just called as derivative or differentiation of that numerator term with respect to the denominator quantity. I'll repeat again. If you have the term dv, all right, if you have the term dv by dt where this v is volume, then it is derivative or differentiation of volume with respect to time. If you have the term, let's say, I don't know, something like dw by dt, it's rate at which work, all right, derivative of work with respect to time, differentiation of work with respect to time. If I have dp by dt, it's nothing but derivative of power or momentum with respect to time. So numerator by denominator, that's how it is. That's how it is. Now I know you are wondering, fine sir, okay, understood. Instantaneous velocity is defined as dx by dt. Instantaneous velocity, I just gave you the definition, is dx by dt. How the hell are you going to find it? Please tell me that. Okay, let's talk about that. How are we going to find it? That's what the main thing is. Okay, amazing. Let's have a look at it. What you need to do, just go back to that slide. Go back to that slide. I want this by this. Zoom onto it. Zoom. Just imagine you have a big magnifying glass, you zoom over there. That curved line, you zoom. These 2 points are very close. Guys, if you zoom onto that, what is that small thing over there going to look like? What is it going to look like? When you zoom onto it, just think. When you zoom onto it, it's going to look like this. There is going to be a curve out there. There's going to be a curve out there. Okay, so there's going to be a curve. The points are the 2 points are over here, but the distance is very small. In fact, you need to zoom in more. This point is actually very close by. You zoom more, you zoom more. These 2 points are coming very close. Think about it. How will those 2 points look like on that curve? It's as if, you know, they are on a small straight line, a very small straight line. Can't imagine, Kalyani, think. They will be on a small straight line. That curve will go away. That curve will become flat. That's what is going to happen. And you will see a small little, if you go on that point, if you zoom over there, what you're going to see on that curve, you're going to see like this. And if you look at it more closely, those 2 points will be almost on a straight line. That curve becomes straight almost. That curve becomes straight. Is that right? Now, tell me one thing. If I extend that line, if I extend that straight line like this, what will that line be called? Tell me guys, what will that line be called? If I extend that line, what is that line called? Quickly tell me. What is that line called? Hold on. What is that line called? Everybody knows this. Excellent, Dr. Prasad. Excellent, Sanjay. Excellent, Sai Shetty. Excellent. No, Arpita. It's not called slope. It's called a tangent. It's not a straight line. It's the tangent. Correct. It's the tangent through that curve. Everybody getting it? So those 2 points, if you that straight line, if it is extended, it's pulled on both sides, that becomes the tangent for this curve. Great. So let's draw the tangent. Okay, that's the tangent. Now there's a very simple thing. What if, you know, I construct a triangle over there? When I zoom over there, all right, when I zoomed over there, imagine at that point I construct a triangle. What do you think will be the height of that triangle? What do you think will be the width of the triangle, base of the triangle? Come on guys, let me know in the chat box. What do you think, that small little triangle, what do you think will that height and that width, that height and that width be equal to? Come on, what do you think this is? What do you think this is? Yup, this will be dx because this is x. And what is this? this is going to be dt. Correcto, dx and dt. Very good. Very good. You guys are thinking very nicely, yeah? You should be proud of yourself. You should be proud of yourself. That's it. Very good. Now, in this right angle triangle, there will be some angle theta. There will be some angle theta. That is a right angle triangle. I hope you can see that. And if I extend the tangent also, obviously if I extend the tangent, this will be also theta. Guys, what exactly did we want? What did we want? We wanted instantaneous velocity. What was instantaneous velocity? Dx by dt. Do you see some trigonometry in this triangle? Ah, I got it. Dx is opposite, dt is adjacent. Opposite, adjacent, which ratio? Oh, it's tan. So that's going to be tan of theta. Now I'll be like, okay, fine. I don't know dx, I don't know dt, and you are giving me a new variable theta. Guys, it's simple. Don't you see it? Just draw the tangent at that point. See where it meets. See where it meets. Just see what that angle is. Just goddamn, just find the tan theta. That's the value of velocity. That's the value of velocity. That's it, done. You don't know dx, you don't know dt, but you know the ratio of dx by dt. Isn't that fascinating? You still didn't get it, did you? Hold on. Just imagine there is some curve like this, and you draw a tangent. You draw a tangent, and this angle, for example, comes out to be 60 degrees. Then at this point, if somebody asks you what is the velocity, you'll be like, hey, it's dx by dt, which is tan theta. So in this case, it's tan 60. What is tan 60? It's root 3. That means it is 1.73 meters per second. Done, done are done. I do not know the value of dx. I do not know the value of dt, but I know the value of dx by dt. Isn't that fascinating? Isn't that fascinating? Did you guys just see that? That ratio, yes, that small triangle, you make it big. Dx by dt, that's the ratio, trigonometric ratio. That's it. That's it. That's how you find instantaneous velocity. Why were you guys breaking your head? Clearo? No need to just be surprised. Oh, sir, what the hell is dx? I don't know value of dx. I don't know value of dt. Don't worry. Dx by dt, you know how. Draw a tangent, measure the angle. Draw a tangent, measure the angle. Tan theta is not dx by dt. That's it. Done, done, are done. So let's get going. V is dx by dt, which is nothing but tan theta, which is also the slope. Is the slope. Change in y, change in horizontal. Change in vertical, change in horizontal. What's that thing called? It's called as the slope. That's it. Nothing else. Clear, clear, clear. That's the slope. So tan theta, all right, is called as the slope of that tangent to this position versus time graph. Write it down in your notes. Dx by dt is velocity instantaneous, which is tan theta, which is the slope of position versus time graph. Very good. Excellent. Let's get going. Now Kalyani, you are asking the perfect question. Sir, will theta be given or not? Solve this question. Now you will see. Yes, Rishabh, मेरे को हिंदी अच्छे से आती है. Okay, but this is an English channel, so that's why we'll be talking in English. Okay, chalo, let's solve this question. Let's solve this question. So we can zoom the graph after PDF is available. Yes, why not? Why not? Okay, okay, come on, guys. I would request the admin not to time out our lovely warriors who are not spamming. Please do not, please do not time them out. Okay, let's see how do we solve this question. This is a position versus time graph, and the question is, when do you think the instantaneous velocity is positive, 0 and negative? Which points out of these points, C, D, E, F? Okay, let's see this. Let's see this. Come on, guys. If I draw a tangent at this point C, tell me, will the slope be positive or negative? Come on, will the slope be positive or negative at C and F? Come on, think about it. If you draw a tangent at C and F, both will be positive. Beautiful. it goes up positive. Remember, I just told you positive, 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 0, 0, 0, negative, 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 0, positive, negative, 0, positive. That's what I had told you. So guys, that's all you need to think. At this point, it is positive. At this point, also it's positive. So positive here, positive here. D point, oh, you draw this line. What does it happen? What happens over here at this point D? It's flat. There is no steepness. There's no downwards. There's no upwards incline. So that's 0, guys. This D is 0. And at point E, you can see it's going down, down, down. So it's going to be negative. Yes, it's going to be negative because, you know, it's going down like that. Now, you might be wondering, sir, what the hell is negative velocity? It's very simple. If velocity is positive, it means you are going on that number line towards this way. That's the meaning of positive velocity. If the velocity is negative, it means you are going towards the negative side of the number line on which you are traveling in motion in 1D. That's all it means, okay? Positive and negative velocity. So those are the answers to this question. Let's do a numerical based question. Also after this, there are 3 graphs. There are 3 graphs. Yes, Nag, we will do it. Don't spam. Obviously, we are going to go in sequence. We are not going to miss the boat, right? We're going to go first vectors, then we went to 1D, then we're going to go to 2D, and then comes an element friction. And let's get going. Let's get going. For this question, what is the, ranking of the car's velocity magnitudes if these are the graphs of position versus time? Come on, think about it. Hello Pratik, welcome aboard. Yes, me infinity, even I know a lot of students will miss Abhishek sir, but yes, I know he has a very good responsibility of taking care of 9, 10, 10 students. So now you guys are here. So come on, don't keep crying over it. Buckle up. Show your your motivation. Show your willingness to learn new things for 11th and 12th. You need to buckle up. Else, if you keep crying over 9th and 10th, then you will waste 1 year. Come on, a lot of students are already ahead in this game. So buckle up is what I would say. Okay, so 2, 1, 3, C. Okay, let's see whether it is the correct answer, and it is because, yes. Look at this. This blue graph, the slope is 0. The blue graph, the slope is 0. This red graph, it's going up, it's positive. This green graph, that is also positive, but this green graph has more steep angle, so it's more positive. Yes, so it's more positive. So the green graph is 2, the red graph is 1, 3 is the blue one, which is 0. That's how it is. Slope is steepness. Very good. Excellent. Let's get going to a numerical problem now. Whoa, this is what you're looking for, right? What is the velocity at 2 seconds? Let's do this. Let's do this. Come on, come on, come on, my warriors. Think about it. What is the velocity at 2 seconds? How are you going to do that? Now, a lot of people asked, sir, the angle will be given or not? Well, if the angle is given, it's simple problem. If the angle is not given, no, you don't have to use right hand rule. Then you need to use your brains, common sense. Look at the problem carefully, analyze what you can do. Velocity at 2 seconds. There is one interesting thing which has been done on the graph. Observe it carefully. You don't need right hand rule. There's one interesting thing which has been done on the graph. You see that blue dotted line? You see that blue dotted line? That's a tangent which is drawn at 2 seconds. This is number 2. Yes, this is 2 seconds. I'll just draw a few more things. Okay, this is 1, this is 2, this is 3, this is 4. This is 1, 2, 3, and 4. Guys, what do we need? We need to find the value of tan theta, because we need the velocity. Velocity means tan theta. This theta is the angle which the tangent makes with the horizontal line. With the horizontal line, that's the angle which the tangent makes. Oh, but I don't know value of tan theta. Theta is not given to me. Am I going to use a protractor? Nah. Look at this. This tangent is passing through this point and this point. It's passing through this point and this point. How about constructing a triangle over here? Look at that. I just constructed a triangle right over here. So guys, now can you tell me what's the height of the triangle and what's the base of the triangle? Right angle triangle. What's the base and the height? Come on guys. It's clearly seen. The height is 3. 1, 2, 3 boxes. 3 units. This is a right angle triangle. The base is 2 units. You can see that. So guys, what's tan theta? It's into 3 by 2, which is option D. Most of you were wrong before. You were saying C and God knows what. Yes, it is 3 by 2, 1.5 meters per second. Some of you said D. Some of you said B. Some of you said C. Be careful. That's how you get it. Now do you understand how to solve the problems based on graphs? Okay, we are going to do more problems. Are you guys geared up? Let's get moving. Viknesh, it's very simple, bacha. Draw the tangent. The tangent was already drawn. See where the tangent is passing from. It's passing from these 2 points, correct? Just construct a triangle. Why? Because I need tan theta. Why? Because that's the velocity. That's the velocity at this point. So it's just like you're expanding the triangle. It becomes big. This side is measurable to be 2. This side is measurable and it is 3. 3 by 2, opposite by adjacent. That's it. That's the answer. Okay. Is that clear now? Yep. Don't worry. Guys, you will have to watch the replay. It's not such an easy topic. Okay, let's get going ahead. But before that, if you have any doubt and whatever difficulties you face, you can ask all your difficulties in the doubt app, which is inside the Vedantu app itself. Okay, take a screenshot, chat with our doubt experts, ask any kind of doubts. You can even ask what is a hint for a problem from any book, from any year, doesn't matter guys. You can ask anything out here. Okay, now let's talk about acceleration. No Mitali, V is x by t, that's gone, done. That's formula is past time. That was school. V is x by t. V is not x by t. Remove it out of your head. Guys, whatever you are taught in school, please remove it out of your head. V is not x by t. Wrong. V is delta x by delta t. That is average. Instantaneous is dx by dt. Please remember this. Please remember this. Okay? Clear? I hope this is clear. Everybody understanding this? Okay? Okay, cool. Let's get going. Now, what is the meaning of average acceleration? Average acceleration, no problem Neha. Average acceleration is nothing but how much does your velocity change? I have done acceleration before this. Change in velocity upon time, everybody knows that. Average acceleration is change in the velocity by time. That's it. Okay, great. Now, this delta, again remember, every time it stands for change. Vf is final velocity, Vi is initial velocity. So if my velocity was this much, now it is so much. The change in the velocity upon how much time it takes is how much it is accelerating. Now that's average. This time is very large. Look at that. If you look at it graphically, from here to here in this time, my velocity has changed this much. You can see this is not position time, this is velocity time. In this time, my velocity changed by so much value. So this divided by this, you can see that it's the average slope. Again, you draw these 2 points, this much is delta V, this much is delta T. That's again the average slope. You can see that it's the average slope. Great. Now, what do you think instantaneous acceleration will be? Think about it. If average acceleration was delta V by delta T, large change in velocity upon a big time interval, change in velocity upon a decent time interval, instantaneous acceleration, excellent SI SETI. Thank you Afaf Azim so much. Excellent. Thank you Rishabh Jain. Excellent. I'm loving my students. Anil, Kavya, Sai Seti. Yes, we are talking about that. We are going to have a special lecture, Arpita, on different kinds of combination problems on acceleration graph and all that. We are going to combine many things. But today it's velocity and acceleration only. Okay. So yes, if that car moves from here to here in a small interval, changes the velocity. Look at that. Look at this graph. In a very small interval, how much did my velocity change? Now, very tiny mini interval, how much did my velocity change? Think about it. That ratio, dv by dt, excellent my warriors, excellent, is instantaneous acceleration, small change in velocity in that time. dv is the infinitely small change in velocity, and dv by dt, like I have been mentioning before, rate of change of velocity with time, numerator by denominator. This is rate of change in velocity. Velocity is there on the top, time is there below. Rate of change of top divided by with respect to that denominator. You can also call it derivative or differentiation of velocity with respect to time. I have been telling you this. Oh, Abhi Tech Telugu, very good. Guys, this is wrong. Acceleration is equal to displacement divided by time square. Wrong. Who told you this formula? If somebody has told you that formula, please never listen to them. Never listen to them. Okay, the unit of displacement by time square is equal to the unit of acceleration, but the quantities are not same. Be careful. Yes, I said dv, this value is much lesser than delta v. Delta v can be 10 meters per second, 0.1 meter per second, 0.5 meters per second, 100 meters per second, but dv, it's very small, close to zero, but not there. Yep, it's only for dimension, correct, Kalyani? Okay. Now, if you look at it graphically, if you have a graph and I ask you, what's the velocity at this point? What will you do? Zoom, 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 zoom. Yeah, zoom it and you will see that curve becomes a straight line. That curve at that point becomes a straight line, correct? And if you zoom on that straight line, you can see a nice, yeah, if you zoom on that straight line, it will become a tangent. Yes, you extend it on both sides, it will become a tangent. And you can also beautifully draw a triangle. You can draw a triangle, correct? And guys, tell me, what's the height of this triangle? What's the base of this triangle? Quickly let me know in the chat box. If you have been following my lecture for the last 20-30 minutes, 1 hour, you know what's the height and the base. Look at that, the small thing on that curve. Look at that, the small thing on that curve. Okay, these are the 2 points. This is a straight line. So come on guys, what is this and what is this? This is nothing but dx, sorry, not dx, this is dv, and this is nothing but dt. Excellent, dv and dt. So guys, that's dv, not dx. This is velocity time, this is dt, this is theta. So what do we want? Acceleration, right? It's dv by dt. dv is opposite side, dt is adjacent side. Opposite by adjacent, what is it? Tan theta. Correct. You got it. That's it. Now you'll be like, sir, acceleration is also tan theta. Velocity is also tan theta. Where is the mistake, guys? Come on, let me know in the chat box. Acceleration is also tan theta. Velocity is also tan theta. How is this possible? How is this possible? There is some mistake. Guys, listen to me carefully. Acceleration is tan theta, but who's tan theta? For velocity versus time graph. Yes, velocity versus time graph. Yeah, but for velocity, when I write tan theta, that tan theta is for the position versus time graph. Yes, the graphs are different. Hi Jia, welcome aboard. So you check which graph it is. So the slope of velocity time, rate of change of velocity gives you acceleration. Rate of change of position, x versus time graph, the slope of xt graph gives you velocity. Okay. How to find displacement? Psi-t, that was the first formula. Displacement, you don't need slope. Just change in position, delta x, final minus initial, that's it, nothing more, nothing less. You don't need slopes for that. Let's see whether you can solve this question coming up on your screen right away. A lot, Sanjay, right? Right now you need to know basic calculus. When you go to 12th, then you will be learning the extensive nature of calculus, and then you will be solving more complex questions. For now, you need to know basics of calculus, that's it, till you learn it in maths. Okay, the velocity time graph is shown below. Okay, for a toy train, during which time interval is the train speeding up? Let's see how many of you can get this. This is velocity time graph. Be careful. Velocity time graph. Come on, come on, come on, guys. Yes, Sanjay, we'll be doing advanced level questions, not exactly kinematics part 2, but when you enter 12th standard, then we'll be doing advanced problems, proper questions which involves those properties also. Yes, we're going to do that, Sanjay. Yep. Okay. D, B to C. Come on, think about it carefully. All right. During which intervals is the train speeding up? Okay. Now look at this. This is velocity time graph. Guys, if you see, the velocity here is increasing. Check the values. Check the values. You can see every new value is higher than the older value. Every new value that you get is higher than the older value. So hence, in this interval, definitely it is speeding up. Yes, from 0 to A, it is definitely speeding up. Correcto. Next, here it's not changing. Velocity is constant. Yep. So it is not speeding up for sure. So this region is gone. B is not there. Okay. So B is out of question. So here, yes, it was increasing. Here, it was constant. So this is not the answer. Here, it is reducing. So C region is gone. C region is gone. No, it's reducing. But what about this D region? Look at it carefully, guys. Look at it carefully. The value becomes more negative. If this is -1, this is -2, this is -3, what is the modulus of them? What is the modulus of them? This will be 1, this will be 2, this will be 3. What are these moduluses called? Modulus of velocity is called speed. Tell me, isn't the speed increasing actually? You can see from this point to this point to this point, don't you see the value has increased 1, 2, 3. So actually in D region, also the speed has increased. Yes, a lot of people think that in this region velocity is decreasing. Nah, magnitude, look at the magnitude of velocity is speed. So actually it is increasing, but from here to here, no, it's going from 3 to 1, speed is decreasing. Look at the mod values. Correct. Yes, so correct answer is actually option D, which is section A and section D only. This section and this section. Okay, a lot of you said A and B, Jala Hasani and yeah, I was seeing others, Shamukh. So the correct answer is D. Yep. Let's see what does each of this graph represent. First one, do you see this is velocity versus time? Is the slope constant or not constant? Let me know. Is the slope constant? Is the steepness constant or not constant? Come on guys, let me know in the chat box. I'm reading all your chats. Is the slope constant or not constant? Come on, quickly. Come on, think about it. E is not 0. Okay, for the previous one, E was positive. Yes, it was constant. Beautiful. Correcto. E is constant. Correct. So E is constant. The slope is constant. Now, if the slope is constant, what does the slope of velocity time give you? The slope gives you acceleration. So acceleration is constant. That is what this graph represents. Slope is constant. Why, Kalyani? If you draw a tangent here or here or here, tell me, does the tangent change the angle? Does the value of tan theta change? That's why it is constant. Yes. Wrong, Hirak. Acceleration is not increasing. Velocity is increasing at a constant rate. Acceleration is constant. Yes, be careful. Acceleration is constant. I hope this is clear. Velocity is increasing. Acceleration is not increasing. Yep. No, this is not uniform velocity. This is called uniform acceleration. This is not uniform velocity. Guys, my God, which school you have been coming from? Please, where have you learned all these things? I think you guys have learned all wrong things in 9th and 10th, guys. Please be careful. Be careful. No. It is not uniform velocity. How is velocity uniform? Velocity is changing, right? Velocity is changing, right? How can velocity be uniform? Acceleration is constant. What is constant? Acceleration. That is uniform. Please do not do that. I'll feel very bad. Okay, no problem. But please try to unlearn whatever you have learned back then. Okay, what about B graph? In B graph, what do you think is constant? Yes, in B graph, what is constant? No. Okay, come on. In B graph, come on, read. Try to interpret what is this graph. Yes, correct. Here, velocity is constant. Slope is, what is the value of the slope? What is the slope? Come on, answer in the chat box. Yes, the velocity is constant. So velocity is uniform. Very good. Velocity is uniform. What is the value of the slope? Yes, the slope is 0. That means acceleration is 0. It is not accelerating. I will say this. It is not accelerating. It is not accelerating. Correct? Got it? Very good. Very good. Now you guys are getting it. I'm feeling happy. I can sleep peacefully tonight if you guys understand all these things. Very good. Now how about this graph? How about this D graph? What do you think? Is the slope constant or not constant? Slope constant or not constant? Because only then I can figure out everything else. Come on. Chiranjeev, Sujay, if you have a doubt in Vpro, you can mail to Vedantu care, vcare@vedantu.com. Okay, yes, slope is constant. Beautiful. Because you take a point here, 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 straight line. It's a constant slope. It is not changing the angle. So acceleration is constant or uniform. Acceleration is uniform. Understand? Acceleration is uniform. Velocity is not constant. You can see velocity is changing the value. Here, here, here. The values of velocities are different. Okay. What about this? What about this? Is the slope constant or not constant? Is the slope constant or not constant? Come on guys, answer in the chat box. Yes, if it has straight line, Shamuk, very good. Then it is constant, the slope. Yep. No, this is not constant. Yeah, excellent, Ankit, Anil, very good. This is not constant. So acceleration itself is non-uniform. Acceleration only is changing. Acceleration is non-uniform. Okay, don't worry whether it is deceleration and all. Acha, if I ask you, is the slope positive or negative? Is this value of the slope positive or negative? Come on guys, let me know in the chat box. Let me know in the chat box. Velocity, yes, Kamal, it is decreasing with time. Come on. If you draw a tangent, is the slope positive or negative? Very good, Sanjay, Adub, Dekshita, very good, Tejuj, very good. It is negative. So the acceleration is positive or negative? Acceleration is positive or negative? Come on guys, answer in the chat box. Acceleration is positive or negative? Very good, it is negative. Excellent, excellent. So yes, we call it negative acceleration, bacha. I'm so happy you guys understood this. Beautiful guys. I mean, if you're there in front of me, I would definitely have clapped your hands and probably given you a pat on the back. Very good, very good. Let's do this question coming up on your screen. This is the last question for today. Yep, last question for today coming up on your screen. Beautiful question. If you solve this question rightly, if you understand this question, trust me, after this you can sleep peacefully after revising through this lecture. Bandaru, it's going down. Down is negative slope. This is positive slope. This is zero slope. Negative, zero, positive, zero, negative. Okay? Okay, Bandaru. Negative slope means it decreases. Positive slope means it increases as you go ahead. Zero means it does not change. Okay. Acha, you want silk? Okay, no problem. Dakshita, on your behalf, I will have one silk. Okay, what is the initial velocity? What is the initial velocity? Check, this is 0. What is the initial? 3. Khatam. 3 meters per second. Done, done, done. Very good. Not meter, meter per second. Very good. Next, what is the acceleration at 2 seconds? At 2 seconds. Tangent? Is this the tangent? Yes. Is this the angle? Yes. What graph is it? Velocity time. What is acceleration? Oh, it's tan theta in V versus time graph. So what is tan theta? It's tan 60. What is tan 60? Root 3, which is 1.73 approx meters per second square. That's the value of acceleration. Beautiful. We got the acceleration at 2 seconds. Last answer. Average acceleration till 2 seconds. You need to be little bit careful with this. The word here is average. What's the formula for average? Instantaneous is dv by dt. Average is delta v by delta t. Delta v by delta t. What is delta v? It is final, this is final, which is how much? 6 minus, what is this? 3. This is initial. 6 minus 3 divided by time, what is it? 2. 6 minus 3, 3. 3 by 2, 1.5. 1.5 meter per second. Seeing it? Look at the difference. Acceleration at 2 seconds. Look at the word, play of words. You should know English properly. At means derivative, instantaneous, slope at 2. That's why tan theta. Average acceleration till. Till means from 0 to 2. From 0 to 2. That's the meaning of the word till. At means at that instant. Till means over a period. That's why delta, a long interval. That's average. Both the values are clearly different. They're not the same. Dikshita, I just explained it. Okay. I hope you just understood it. So this is instantaneous. For instantaneous, you draw the tangent, measure the tan of the angle. That's what I've done. For average, you need a time interval till 2 seconds. What is the change? This was final velocity. This was initial. Change upon time. Anytime you have average, it's a big height by big base. For instantaneous, it's small height by small base. It's tangent slope. Psi at 3 seconds, I don't know. You will have to draw it and you have to measure it using protractor. I don't know. It could be anything, right? I don't know. Okay. Okay. It will not be the same, but it will be different. At 3 seconds, I don't know. Maybe it is, I don't know. Let's say 45 degrees. Example. So this is, let's say, 3 seconds. So what will be the acceleration at 3 seconds? Come on, guys. It will be tan 45. What is tan 45? Quickly, let me know in the chat box. Let me know in the chat box. Let me know in the chat box what is the answer for this one. Yeah, very good, Sandhya. Very good, Sai Seti. See, you only answered it. It is 1 meter per second square. Got it. Beautiful. Amazing. Amazing. Guys, that's all derivatives. I mean, now you need to revise this. You need to watch this lecture 2-3 times. Guys, every time you watch this lecture, you know, it's going to cost you what? Nothing but time, nothing else. You don't have to pay anything extra to watch this lecture again and again. Please watch this. You will need it. Very good. Very good. Yeah. This is your first homework. Let's see how many of you are going to post the answers in the comment section. I'm going to show their names and let's see who answers really quick tonight. That means they have understood it well. This is your first homework question. Take a screen grab of this. Yes, take a screenshot. And this is your second homework question. Take a screen grab of this. Yeah. Let's see how many of you are going to post the answers in the comment section. I'm going to show their names next lecture. And by the way, there's also a link for joining our subscription and I'll tell you what and all you're going to get in the subscription out there. Okay, so you go in our video. Okay, thank you. So there we go, below, and we have crash course, but you guys are 11th standard kids, right? So you don't need the crash course right now. You need 2 years for that. But if you don't want to buy this course, you know what you should buy? You should buy this one, because I'm pretty sure you don't want to crash right now, or you don't want to crash later on. You want to learn everything properly. So that's where you go to pro subscriptions out here, and in the pro subscription you get revision, you get the entire syllabus completed 11th and 12th till JEE 2023, 2 years batch. Topic wise short courses, other courses, 3 versions. The light has everything like the Tattva module, the doubt section, the best master teachers like me, and the the test, the analysis, everything, assignments, hard copy of Vedantu material called as Tattva, all of this. But you don't get a personal mentor. You need to pay a little bit extra for that. That's available in our plus version. And if you want all the doubts to be solved on the mobile app, yeah, you need to pay a little bit extra. Now don't get scared by these prices. You look at this, EMI option is also there. Yeah, you don't have to pay this entire amount. Just pay 3,000 per month. I mean, come on, you are in this course. And when you use this coupon code, beautiful coupon code, SHHPRO, amazing, 10% off. Yeah, that's a great deal. And guess what? Even for the highest version, yay, there you go. It's just 6,750. Oh no, it's 4,500 per month. 4,500 per month, guys, for a personal mentor with all these things, with KVPY, 2 years. Guys, your board tuition teacher charges more than this. Board tuition teacher will charge more than this. What more you want? You don't have to go to Kota. You have got the best teachers out here. Go ahead for it. Go ahead. use the coupon code SHHPRO, and I'll be talking about it in detail in my Wednesday class, which all courses you're going to get in the pro subscription out there. Remember that. Okay. So thank you guys very much. Thank you, Deekshita. Yes, Kalyani, see you again. Well, Sonu, I see you again. Next class is going to be on Thursday. Yeah, Thursday. Correct. Zero to Hero is done. Nivedita, we have started with Rank Booster series. In the morning, I conducted the first class of Rank Booster series, which is on kinematics. Yes, we did on kinematics, projectile motion. Watch it in case you missed it. Yes, dinner time. Bye, guys. And yeah, post up the comments. I read all your comments. It will make my day. Please post some lovely comments after the video. I'll be waiting to read all your comments. Yeah, thank you guys. I hope you enjoyed the session really well. Glad. Thank you, Ataf. Oh my God, that means a lot. Post it up in the comments. I will read it. I will keep reading it, and you'll feel very happy and you'll get good sleep tonight. Bye bye, guys. See you. Hasta la vista. This was Shreyas here, your physics master teacher at Vedantu going live. Bye bye.